Good morning, ladies and gentlemen. We're presenting here today. We're going to do our water outlook for 2021. I'm Terrell Sorensen, Extension Educator out of Power County. One thing about it has been a crazy year, but water is like that every year, I guess you could say. It's always a crazy year. One of the things I wanted to do to start with is I wanted just to look at the Snake River Basin as a whole. We talk about it, for us here in southern Idaho, we kind of look at it as just a one piece. But really the basin is a pretty good size. When you look at it, it goes all the way from a little above Moscow, all the way down, covers part of Oregon, most of southern Idaho. It's about 108,000 square miles. It's 1,078 miles long. One thing about it is the average discharge is over 54,000, so we're talking about a lot of water. It encompasses 6 states, just a little tiny bit of Utah when you think about it. It's also the 10th largest North American river. So you can see it, we got a big geographic area. A lot of times we don't talk about it. I wanted to just discuss a little bit. So when we talk about the Snake River Basin, we irrigate just over 3 million acres out of this. We do a lot of irrigating out of it. We have 22 hydro dams on the main stem of the Snake, about 15 in Idaho, 4 in Washington, and 3 straddle the Idaho-Oregon border in the Hells Canyon complex. It's a big deal for Idaho Power. It's one of the reasons they're one of the biggest renewable energy in the United States right now. We produce about 1,100 megawatts electricity from this. And if you look at the slide I got there right now, that's the first dam on the Snake. It was on the main stem. It's the Swan Falls Dam. It was made in 1900, basically to provide power up to the miners up and above Boise. The last dam was 1975, the Lower Granite Dam down on the lower end of the Snake. So we're talking about what's our water outlook for the year. When I start talking about the total water, I kind of break it down into what I call the carryover from the last year throughout our big reservoirs. We talk about the base flows, spring flows, river flows. Then I have what I call a yield of the watershed. How much water are we actually going to get off our watershed this year? Kind of looking ahead a little bit. We look at it, let's look at our carryover this year. We got a comparison there between 2019, 2020. You can see we're just slightly below last year's. I think we're about 70,000 below on the Boise system, just about right on the average, 30-year average. The Waihe, we're a little bit just above average on that. Last year we had a lot of carryover on the Waihe. We're getting down there. We're down about 145,000 acre feet. The Upper Snake, we're still in good shape on it. But we can see that we had a drop this year. And we really did have a good water year, so we used a lot of water this year for a lot of projects. We did a lot of recharge. We run a lot of power water. So we did a lot of things. We flushed a lot of water down for the salmon. You see, but we're still about 100, almost 200,000 above, our 30-year average. Still in good shape. The Payette, it's a little tougher year. We're getting down now. We're just below average, about 20,000 acre feet on the Payette system. This is some of our major systems that we have. The one thing that to look at, though, is where our carryover is pretty good. But we need to remember, too, we had a very dry, from like the 1st of July to right through to now to December period. We got very dry soils going into the winter, which was really going to affect the amount of runoff that we get out of our snowpack this year. And also we had such a good growing year and a good harvest season. I don't know if we've had a better one, but part of that is we got the ability to pump. We're keeping things wet, we was able to harvest when we wanted. So we had a lot of groundwater pumping in late this year. We kept the canals, pumping systems going for a long time this year. So we did use a lot of water late. That's one of the reasons we looked like we were going to have a lot of carryover this year. We ended up, even a little bit less than last year. So the dry summer and fall kind of equals we did a lot of heavy groundwater pumping. We're kind of the opposite of where we were a year ago right now. You think a year ago we had a lot of, good September, October rains. It was kind of a wild weather. In fact, you remember we had the frost come in October. It was really a tough year to get the harvest in. We're just almost exactly the opposite this year. So a lot of our, our future right now is what we're going to get from here on out. So let's talk about the yield of the watersheds we're going to get, determined by our precipitation, rain, water that we're going to get. Hopefully we're starting, maybe they're talking this weekend, we're going to get a weather pattern change. You don't know, we get such wild weather pattern changes anymore. We can go from very wet. You remember back in May, June this year, we had a wet period. A lot of it too is their temperature when the runoff comes and occurs. If we get a hot season in the early June, we get a lot of runoff then. If we get a slow one, especially where we take our soil conditions where they're already dry, we're going to get a lot of our runoff will be going right into the ground. Another one that I like to talk about too is our noxious weeds on some of our watersheds. I think if you look below there with the definition of a watershed, it's land area that channels your rainfall, snowmelt. Can either be very large or very small. I know of some of the watershed areas, some of the small watersheds. Particularly, I know one where there's a creek up there that, we got about 150 years of history on it. We've got noxious weeds up in the watershed area. I think it was 2012 was the first year that creek ever went dry in the summer. It's been going dry every year since then. But what happens with that creek is kind of amazing is 2 weeks after the frost, a killing frost comes, the water starts running again through the creek. So that's what's telling us is our noxious weeds are really sucking on our aquifer, taking out the spring areas. So we're trying to do a lot of work in those areas, try to help those. But it does make an effect on our overall yield on our watersheds. A lot of vegetation on some of these smaller watersheds. We're getting a lot of some of our junipers and that's getting pretty thick stands. It does affect our watersheds. And also our aquifer levels affect our yield of our watershed. The reason I put this slide up, this is kind of a general slide that we put for the Upper Snake Basin. It shows all the little tributaries that come around the basin. You can see we got several of them there. We got some watersheds in pretty good shape. Some are in a little tougher shape. You look down here, we go clear down into the Utah and a couple of them on the Raft River Basin. Our watersheds, a lot of them have got some problems with them that we need to work on that does affect our yield. One particular that they're working on pretty hard, we got a study going on they're going to spend over about $1 million to the Raft River Basin, try to figure out what's going on with it. They say the aquifer there is still dropping on an average of about 1.75 feet per year still. So it doesn't take a lot of years to go deeper, and they're still talking about some recharge water from the snake. Anyway, to kind of sum up what our outlook for this coming year on our water is, we're going to need a really wet winter and spring coming up. We got some catch up to do. We got dry soils, like we said. We're going to need a lot of moisture for here the next 4 or 5 months. One thing we've really had lucky the last few years is we've had really good water years. We don't want to go back to the drought. Changing gears just a little bit here, we'll talk a little bit about what's going on in our next door neighbor states there a little on their watersheds. I just got a picture here of the Iron Gate Dam. It's going to be the largest dam on the Klamath River system to be demolished. There's probably start work in late 2021 on starting to decommission it, drain it down. They think it's going to take about $450 million on the 4 dams on the Klamath they're going to take out. The one thing that was interesting about it is Pacific Corp originally was going to have to pay about $400 million to allow their relicensing to cover some of the costs. So they told the state of California, stepped up and said they'd pay $250 million if we took out the 4 dams. So they jumped on it and said, we'll pay $200 million. California's going to pick up the rest. One of the things that too they've said about that is to make up for the difference in the megawatts that they're going to lose is they're putting bids out for people to bring, new renewable energy sources is what they want. So what they're talking about, 1,823 megawatts of solar. They want about 600 megawatts of new battery storage. This is kind of a new concept that's coming in now to the industry. And they want about 1,900 megawatts of new wind resources by 2023, which when they start decommissioning, those dams will be going out then. This is just a little picture here of the Klamath River Basin, just right over on the Pacific coast there. It covers, the lower part of Oregon and the upper part of California. The interesting thing is, I think you got to look at real hard. If you remember this last summer, how wild it was. They had rolling blackouts in California this past summer. This is October 20th. They come out with the Public Utility Commission in California. What they're saying is this is what it was due to, the extreme heat wave that hit right then. But another one was the growing amounts of renewable sources. When the sun went down and it's still hot, your power load just dropped drastically. The other thing is the energy market kind of exacerbated the supply challenges too, that it was tough to move the power where it needed to be. We're so intertied right now. But it's something to think about. We're taking out, hydro, very reliable. We're going more to our solar and that. We have to come up with some new ideas. Anyway, changing gears just a little bit more, we're kind of talking about what I call a 2-river system. This year in the state of Idaho, we had one of our water attorneys. His name is Roger Ling. I worked with him for about 30 years in the irrigation business. We got to be good friends. He was kind of a real mentor in the water business. And one of the things that Roger kept talking about is to understand water and to be able to do much with water, you got to know the history of it. And he was really adamant about that. He worked alone a lot of the time, and we was always trying to get him to get somebody to help him. So when he retired, he'd have somebody to come on, but they would never understand the history good enough for Roger. They'd come and go, and Roger just say, you got to know the history. But he passed away this fall, and so I just kind of threw this in, kind of thinking about Roger about that. I don't think Idahoans really understand water system, the way it works a lot of times. We always call it a two-river system. The picture here is of the Milner Dam. This is more or less just a diversion dam just below Burley here. What it does is it diverts to the major Twin Falls Canal, north side, Milner Gooding, Milner Irrigation, then there's a couple of them further upstream that divert to out of it. But what it basically does most of the years, and a lot of the times, is we use everything up when it gets to that point. In other words, this picture shows a lot of water running down the river here. Actually, during most of the years, even during the winter, is we have zero flow past that. In other words, we're stopping the river right there. But you go down just a few miles and here we got the river running again. And I don't think people realize how much of the river we actually use right there. Because, we got the 1,000 springs that regenerates. And that's basically what's running the river system on down through the middle and the lower Snake. It allows us to do a lot of different things, the recharge. The recharge is getting more dependent each year on those spring flows. This last year in 2020, we totaled over 450,000 acre feet, which is, we're looking to get 250,000. We had a very good year on the recharge areas, which always does help our spring flows. This next one we're talking about, that looks like, what are we talking about wheat for? We're going to talk a little bit about wheat, sugar beets, and potatoes a little bit right here. I just thought this was totally fascinating when we'll relate back how it deals with water too a little bit here. But this, it's just a little simple slide here. It's starting to show our wheat yields. We go back to 1964. We're averaging, this is the wheat yields on a total wheat, for this is both irrigated and dryland wheat in the state of Idaho. We start out, we're averaging about 39 bushel per acre. You can see we go along in the 1980s. We're getting up there around 79, 80. This year must have been the perfect wheat crop of all times. For the state of Idaho, it was anyway. We were up to 101 bushel this year, which is actually pretty phenomenal. When you think about it, dry land, irrigated, a great wheat crop this year. But one of the things we're talking about also is the amount of water that's being used. We'll look at it a little bit later that the actual water use has actually been going down on these. So that's pretty phenomenal when you think about it. It's like a lot of genetic modifications going on, better farming practices. You can see too that we've been going down in acres during those years, but we're still growing more wheat. Here's the one that's really kind of astounding, is right here in the sugar beets. I used to be a loan officer back in the 1980s, and we always plugged in sugar beets 20 to 24 ton to the acre. Basically, we were averaging about 23.1 back in there. Good years, you might get 28. Replants, you'd probably be under 20 tons to the acre. You can see we go along, you get genetic modifications again, new farming practices. You see right now we're up to about 40.5, 41 tons per acre average. A lot of guys are even hitting the 50 ton or above range. But what's also interesting about it is not only is the tonnage coming up, but our sugars are also coming with it. I've talked to a lot of farmers this fall that said they were just approaching on their entire crop close to 20% sugars. And you think about it, in back 15, 16% sugars were pretty good. So you see not only we doubled the tonnage, we were actually really adding the sugar. You figure that out, we've gone to about 3 or 4 tons of sugar per acre to we're up to 8, 9 tons of sugar per acre now. Huge strides made in that. And basically we're watering the crop pretty well the same way that we were before. We might be getting a little more consumptive use out of it, but we're being more efficient with the water. You can see too, we're growing just a few more less acres than we used to grow. Now here's the potato one. This is just about like the sugar beets. We started back in 1964. We were averaging about 164 sacks the acre. That's statewide. Some of us can remember 1964. It wasn't that long ago. And you look, it's just been a steady climb over the years. We're up to 425 sacks. And that's an average. There's a lot of guys that are way above that. But as an overall crop, that's about where we are now. And you think about that as how many, fewer acres or how much more product that is. We're basically probably more efficient with the water. Back in the 1960s, it was all pretty well hand moves, things like that. We're more efficient with the water now. There's probably more consumptive use of the crop, but we're still using less water. You can see how our acres climbed up and kind of peaked around 1992. I've been coming down a little bit since, but we're still growing a lot more potatoes. Here's a study I found in the University of Illinois. They looked at the U.S. water withdrawals in U.S. ag and food production from 95 to 2010. They're showing a decline in the water use. They say it's 8.3% over this time frame. Now you think, well, that's not much of a deal, but that is a big issue nationwide. We are using less water for irrigation than we were back in the 80s. Traditionally, your scientists would measure the amount of water based on their crop water use models. Right now we're getting some real data there, and we're starting to use real data models, and we're getting different trends, conclusions. But you can see where the ag is still a big user of water. We're using 97% of the water in the state of Idaho. 3% is going to other uses. So we're huge doing that. This is a slide put out by the USGS showing the total water use is down. You can see how it peaked back in 1980. They've been on a downhill slope since. You say, well, what difference does that make? When you're projecting use, they used to project, that it was a steady climb up. We'll be using more water all the time, but we're becoming much more efficient with it. We're doing a lot of good things with it. So irrigation peaked in 1980, and the surface water use is declining. You think about this, that we're making better use of our water. Well, one of the amazing things is a lot of our farm ground has been that's going into housing now, is your best ground. So we're taking that out of production, but we're still coming up on our yields and production. But it kind of worries you sometimes, I guess. You think about some of this good farm ground going out, but we seem to keep on trucking. Okay, our surface water has kind of replaced some of our groundwater. Consumptive use is increasing like we talked before. You can see how much we were totally back in the 30s, the 40s, the early 40s. We just all exclusively were surface water. How we've kind of switched over now. We use a lot of groundwater. This put together by the Department of Water Resource. You can also see our MNI Water has also been on a decline since 2000. The reason I bring these up is that you'll show this next graph here. This shows the Boise DC MNI Water Use. They're projecting for 30 years out. You go back there, they were projecting back in 2000 that we were just going to go on a steady climb. The Boise Valley was going to grow, which it has. But our water use has basically stayed just the same. When you look at that one straight line through there, it's gone up and down a little bit. They're still projecting, we're going to go on this crazy deal. And what happened is a lot of your cities and your municipalities were out buying up water, trying to build more dams, getting more water. And that was a big deal for them. Here's one for Seattle. You talk about the Boise area. The Seattle one's being even more dramatic. It shows that they thought they were just going to spike clear through the roof there. But you can see we're actually using less water than they were back in the 1970s through different conservation and things like that. Interesting thing when you think about it. I want to talk a little bit about maintenance. One thing that's going on in the central Idaho now, you talked about the American Falls Dam. That's kind of the major hub of the Snake River for this entire southern Idaho. It kind of runs the whole river system for us down here. We're doing a complete spillway rehabilitation. We started in June 1st, 2020. It's going to be going through to December 31st, 2021. That's when they're supposed to be done. So one of the things that's happening is they're having to switch water around a little bit. You'll see different flows. If you get on and look at the USGS website, look at the river flows, they're a little bit different than they are a lot of years. You'll see right now we're putting out more water than we usually do this time of year, but we're actually not putting out more. We're just catching it down in Minidoka Dam. They're trying to keep the level low as they can so they can keep working until the first of the year. Right now they're up in the spillway area. They got doing a lot of concrete work. They're going to try to keep going as long as they can this year till it gets up to the spillways. Another reason I bring that up is it's really important in the water industry to try to keep, rehabilitation of these facilities going on. The last few years we've been able to get more of these projects going on. It seems like your maintenance work sometimes gets pushed back. So it is really important. You look at the federal legislation, there's a couple of things we want to keep going is the one's the drought resiliency and water supply. That's the one that helps with the Bureau of Reclamation and putting money on the table for us so we can do these type of things. Another important one that we have on legislative when you look at the water outlook is the aquifer recharge flexibility. I know Senator Risch has been working on that one with a couple of our congressmen from Idaho. What that does is allow the federal use of like our Bureau of Reclamation facilities that they can do recharge. Right now they're not supposed to do the recharge during the winter, but it'll allow us to start using our facilities and our canals and our lands for recharge activities. It's really a big deal, when you think about it. Another one that we've been working on pretty hard is the Columbia River Treaty. Negotiations with both countries is continuing, been working hard on it. I know a lot of people here in southern Idaho are working pretty hard. It's a really big deal for this. Think back on that Snake River Basin. That's what we really need we need to be able to still run our water in this area. We don't need to take more out. Another deal we got is the Idaho Salmon Work Group. Our salmon numbers have been falling again. We're trying to figure out what's going on with that. We want to get those coming back up again. Another one that we're working hard with is title transfers to the Bureau, from the Bureau of Reclamation on paid out projects, so that they can get actual control of their facilities. It's a big deal in the water community. I'm going to talk just a little bit in closing up here. Some new water terms. You know, it's been kind of a wacky year. You talk about the new term out there is what they call eco-labeling. And the joke is, how do you get 130 liters of water in one cup? You just fill it with coffee. That's what it takes to produce that. What they want to do is they put eco-labeling on our food manufacturing, on some of our clothes even. They want to put it on how much water it takes, how much carbon dioxide, labor associated with production. In other words, it's 10,000 liters of water in a pair of jeans, 2,500 liters of water in a t-shirt. Another one that they're talking about that's interesting, you see out there, is what they call virtual water. You think about this year, maybe that's appropriate to have virtual water. We've kind of done everything else that way. But what it is regions that export water-intensive crops are effectively exporting their water. In other words, if we ship beef or whatever, we're shipping water is what it amounts to. Another one that they're kicking around too is they want policies aimed at affecting consumer behavior, such as increasing taxes on water-intensive products. And that's kind of a scary thought when you think about that. You know, I like steak too. Also, another one they're doing is future exchanges in Australia, becoming speculative, just like you're trading oil, crude oil. Some crazy things going on. Another one just to throw in is, it seems like this year it just keeps going up. I got 844 million people don't have access to clean, affordable water within 30 minutes of their homes. I know if my water goes out in my house, I better get it fixed. But you think about that, that is huge in people's lives. Not only that, it's also, you know, that if they don't have clean, affordable water, they don't have any facilities, you know, their sewer systems are non-existent. So you can see what a dilemma that is. This is, I've always closed up on this slide. This was originally taken from India. I don't know if it was in Portland this year or not, but it's kind of what's going on in the world sometimes. You get into some of the water situations. We hope we don't get there. We need to keep solving problems. Anyway, I just thank you for your attention, and that's it.